Okay, we're back talking about how we can maximize our income and referring to an example that I started with on a different video and kind of looked at things in a discrete way. But this time I'm curious about values that I don't see in these tables. What about in-between values in consideration of maximizing my income? So remember that we said that income was the revenue minus the cost of purchasing. And if I apply my two formulas that I've written down here, remember that P with a subscript U is the price per unit. This is the price that you're putting out there for your customers, okay, for each little widget you're selling. S is the number of units sold, and the revenue is P subscript U times S, the price per unit times the number of units sold. The cost per unit is labeled C with a subscript U, and N is the number of units purchased in this table, so that the cost of purchasing is the cost per unit times the number of units purchased, such that, that's this colon, such that the initial cost of purchasing is 0. So I'm using that for this specific example, just like I did with the last example in the other video. So let's take again a look at this income. The income is revenue minus the cost of purchasing, which, if I use my little formulas, looks like this. Okay, price per unit times units sold minus this guy, the cost per unit, times the number of units purchased. However, and this is exactly the formula I used to come up with different incomes for these different scenarios in the last example, but I'm curious about the in-between values. What do I mean? I mean, what if I sold 6 units instead of 5 or 10? What if I purchased 6 units instead of 5 or 10, for example? I want to know exactly the whole number of unit I can use to maximize my income. And to do that, I'm going to apply a little bit more algebraic techniques. Let's take a look at just the revenue section first that I have here in pink. Is there any way that I can relate these two numbers together somehow so that I can get some sort of continuous flow of the numbers? So not just 5, but if I can take this initial data and somehow relate these sets of numbers, I should be able to come with, for example, if I sold 6 units, how much I should charge per unit. Or if I sold 11 units, how much I should charge per unit. And I want to do the same thing with the cost structure. So you have to notice a little something about the data and the tables to do that. And first of all, I noticed that it seems like this is going down in a discrete amount as the number of sales are going up also in a discrete amount. So I'm going to assume that there's a linear relationship between the numbers in the left column and the numbers in the right. If there's a linear relationship between those two numbers, then I can use the y equals mx plus b form of a linear equation to perhaps represent this data and more, right? I want to represent even more data than what's showing, or I want to predict. So if I use this y equals mx plus b thing, remember m is the slope of that linear equation, and please review linear equations if all of a sudden this is totally foreign to you. Review linear equations and then come back to this video. If I'm going to use this y equals mx plus b form and use the notation that I have here, then I could say this. I could define, for example, the price per unit in terms of the number of units sold, or the other way around. I'll just do it this way, the price per unit. So I'm going to say this is like my y, and this is like my x. And I want mx plus b. M is the slope, and so we're going to define it this way. I'm going to say, all right, this is my change in price per unit over change in number of units sold times the number of units sold plus some initial quantity. And so in this form, I'm saying here's my y equals mx plus b, just to relate it to some things you've probably heard about before. So let me define my changes here between any two values. Let me just pick the first couple values, okay? So if I go from 600 to 550, then I've changed by 50. 600 minus 550 is 50, right? Now I've got to go the same direction and use the same corresponding values when I go define the change in the S's, okay? The number of units sold. So this time I'm going to say, defining the change in the exact same way, 5 minus 10 is negative 5. So 50 over negative 5 times S plus some initial quantity there for price per unit sold. I can keep going with this. This gives me negative 10S plus this initial quantity. And how do I find the initial amount? I can just plug in any set of values from this table that I already know. So I'll just start with the first one. Let this be 600 equal to negative 10 times, I have to put in the corresponding S value of 5 plus this initial value on the end. This gives me negative 50 plus this initial value. And what I'm trying to do right now is find this initial value. And I have enough information. Add 50 to both sides of this equation. 650 is equal to the initial value here. You might have been able to ascertain that in another way, just looking at the table. But overall, now I can say, okay, I have enough information to generate an equation for that table. And the equation is, I guess I'll stick it up here. P subscript U is equal to negative 10 times the number of units sold plus 650. Now, what have I done with this? What you'll notice is that if you take one of the units sold, like take 5 and put it right in there and use the equation, you'll get 600. If you put 10 right there and use the right side of the equation, you will get 550 for the price per unit sold. But you'll also get in-between values. Let's say I have 6 units sold, then you can predict a price per unit there that matches the rest of this data. So this gives me all those in-between values I wanted. I'm going to do the same thing with the cost structure here. And just for symmetry here, to match it all up, let me define some kind of cost per unit in an equation. So I'm going to use another linear equation because it appears to me that the set is linear, the set of data over here, which means that this is changing by fixed increments. Also, this is changing by fixed increments. If I have like maybe 5, 10, 20, 100, and it doesn't change in fixed increments along with this, then it may not be linear. So you got to be careful with that. But I'm going to assume linearity. I think it's true. And we're going to do a y equals mx plus b kind of thing again. So I want to define my change in cost per unit over my change in number of units sold, and that's like the slope of the linear equation, times number of units sold plus some initial value related to this cost per unit equation. And now I'm going to keep going from there by plugging in numbers. And let's just say we went from 500 to 475 for my change in cost per unit, so that's a change of 25, 500 minus 475. I'm going to go the same direction. 5 minus 10 is negative 5 for the number of units sold. I still have my times n plus this initial value. Keep going. This looks like negative 5n plus the initial quantity. And now I want to find this, so I'm going to plug in a value for n and my cost per unit given by the table. I'll just start with the first one. So I can say that 500 is equal to negative 5 times 5 plus the initial quantity here. That gives me negative 25 plus that initial value, which means add the 25 to both sides of the equation. 525 is equal to that initial value, and I have enough information to generate an equation for my cost per unit. I can then say my equation is equal to negative 5 times n plus 525. And once again, what that does is it sort of smooths out all this data, or gives me the ability to have in-between values not showing here and get values on the other side that you don't see that match with the whole pattern. And that's kind of what I want to do. Now, what am I going to do with all this? Well, I still want to define the income. Notice that I have a price per unit here. That's this entire equation. I have a cost per unit here. That's this entire equation. So let me take those two equations and plug them into my income formula or definition. And I'm going to need to erase a few things to make some space to do that. So now's the time to heat up your cup of coffee or whatever. Drink some water. I'm pretty thirsty. Smoke a cigarette? Nah, it takes too long. It's not good for you. Known to cause cancer, Surgeon General warning, yada yada. Smoking is bad. Everybody hates smoking, which is why some people still like to smoke. Right. Okay. Not everybody hates smoking. I actually really like the smell of cigarettes. No doubt due to friends and family. Okay. And even my own sordid past. Let us go ahead, now that I'm back from erasing and all that other junk I just said, plug these two fellows into my income equation where I see them there. So if I plug this one in, I'm going to say, let's replace the PU with some parentheses, and I'm going to put the stuff on the right-hand side of that equation in there instead. Negative 10s plus 650 s for this s on the outside. Minus parentheses, I'm going to use this equation for my CU. Negative 5n plus 525, and I've got an n on the outside. If I distribute the s here and I distribute the n there, then I get negative 10s squared plus 650s. I also have a negative that needs to be distributed, so I'm going to do them both at the same time, and that's going to be a little tricky, so make sure you feel good about this after you see this equation. If I distribute the negative, it changes the signs. If I distribute the n, it plugs an n onto each one of those guys. So I'm going to get a plus 5n squared minus 525n. Now remember, I think in our original example we said, let's go ahead and try to sell every unit that we purchased. So I'm saying let us go ahead and try to make this possible. Okay. If the number of units that we purchased for that time period is equal to the number of units that we sold for that time period, then my income equation becomes the same thing it is here, but I'm going to use one of these values as the same as the other one. So let's say we want to maximize our income in terms of units sold. That means I want to keep an s in my equation. So I'm going to say this is negative 10 s squared plus 650s. And where I see an n, I'm going to replace it with an s because I'm trying to let those things be equal. So this is plus 5s squared minus 525s. Now that I've done that, you'll notice that we have some like terms there. The negative 10s squared plus 5s squared gives us a negative 5s squared. And then the 650s minus 525s is what, 125? So I'm going to say plus 125s. And there is my new income equation. In specific, in terms of number of items sold at our store. Now it's a very interesting equation, and what I want to know is how do I maximize my income for a particular number of units sold. And there are different ways to do that. There's a method in calculus that's real quick and easy to do that. Now let me erase some things because I feel like I need a little bit more space now. So here's another period where you can go to the restroom or do whatever you got to do. don't know why I'm trying to preserve this so well. Because I'm going to write it up here. Check your cell phones, text a friend right now, tell them, hey, check out these videos, maximize your income in terms of the number of units sold. All right. Isn't math fun and interesting? There are simple ways to do things. There are a little bit more complicated ways to do things. And they have their advantages and disadvantages in time and money spent. It's just fun to think about the balance. A lot of people pay accountants, but it's worth it for a lot of people. Okay, so here is my new income equation, fancy schmancy, in terms of number of units sold. And it's kind of interesting. It's a quadratic equation. And if you were to graph this thing, we could graph it like this. Okay, maybe number of units sold this direction and our income this direction. The negative right here in front of my s squared term tells me that it's actually a downward facing parabola. If we have 0 items sold, we can see that the income is 0, so I could start there. And it looks something like this. Okay, kind of keeps on going that way. It keeps on going this way too. Some of this graph is meaningless. What I really want to know, I definitely don't want a negative income, which is interesting. According to this, if you sell too many things, you're going to have a negative income. How come? Because of the cost structure. Okay, so be careful there. But what I'm interested in is this point, right there. This is my max income on the graph, and this is the number of units sold that corresponds to that max. Okay, and how do I find that? Well, you might remember that you can apply the vertex. Okay, this is the vertex. To find the x value of a vertex, we say that x is equal to negative b over 2a, and I'm relating this to a standard form quadratic equation. I'm relating it to this, ax squared plus bx plus c. Now I'm going to apply this general algebraic idea to this particular equation where my y is my I and my s is my x. So if I want to find the vertex here, I'm going to say s equals negative b. Now why am I calling this b? The b term is the one that has the x, but I don't have my constant term out here. That's 0, so it's the c that I'm missing when I relate it to this equation. So I'm going to say s equals negative 125 over 2 times negative 5. And this gives me, those negatives cancel, so this is 125 over 2 times 5 is 10. 125 divided by 10 is exactly 12.5. So it turns out that for this example, exactly 12.5 units purchased and then sold is going to give me my maximum income. And what is that maximum income? And I'm going to come back to that 0.5. You're probably thinking about it, right? What's my income if I have 12.5? Well, this would be negative 5 times 12.5 squared plus 125 times 12.5. And that comes out to 781.25. Okay, so that's my technical max there. 781.25. If I could, in fact, have 12.5 units purchased and 12.5 units sold. Now, my guess is you probably can't. You probably need 12 or 13. So let's go ahead and take a look at what is it when I use 12. Okay, so for 12, I'd have negative 5 times 12 squared plus 125 times 12. And that comes out to $780 as our income. If I use 13, let's check that one. Negative 5 times 13 squared plus 125 times 13. That is also, interestingly enough, 780. So kind of symmetric right around these two guys. If I only get 12, okay, let's relate that here, or if I get 13, so we'll say that this one is 12, this one is 13 exactly. And if I do that, either way, I end up with 780. And I think that's the best I could do. I probably can't do the 0.5. So originally when we answered the question, I believe we said 10 or 15 units was the best. Now we're saying a little bit more precisely 12 or 13 units the best. If it were me, I would probably go with 12, thinking about having to move one more item and how much my back hurts. So I hope you've had fun with this video. Stay tuned for more fun and exciting math.